Welcome to the Tool Lending Library at the Smart Building Center, an energy efficiency innovation space for commercial, institutional, and industrial building operations. Our focus is where smart meets safety, comfort, and efficiency. We offer state-of-the-art training and meeting spaces, instructional educational materials such as this training video, and our tool lending library offers a wide spectrum of monitoring and diagnostics tools for free. Today, we will demonstrate the AirData Multimeter, ADM-880C. We're going to demonstrate how to use it in combination with a pitot tube to measure the airflow going through a duct into our space, the reception area. So why do we want to know the velocity of an air stream coming into our space? Well, one component of a healthy indoor environment and indoor air quality is the rate of outdoor air being supplied into a space. ASHRAE Standard 62 gives some guidelines on how the rates are. We're going to measure the velocity in a duct today in a reception area, and the recommended air CFMs to be supplied into that space according to ASHRAE is 5 CFM, which is cubic feet per minute per person in the space, plus an additional 0.06 CFM per square meter of the space. Today, we'll be measuring the air velocity using our AirData Multimeter ADM-880C. This is a very versatile tool, and it comes with various probes. It comes, for example, with this grid. It has an airfoil. The airfoil is used to measure velocity, like low velocity, not with very high speed. We have these static pressure probes. It also has a couple temperature probes you can use, and this pitot tube. And this is the meter itself. It can also be used with a flow hood, which we also have in our inventory. But for today, we're going to demonstrate how to use the pitot tube. So before we can use this and take our measurements, we have to connect and set up the meter for our use. So the kit in here has these double hose, and one of these hoses has a white stripe. We're going to use that to connect to the positive port. The positive port on the pitot tube is here at the top. So we connect that hose there, and the other just plain black hose will connect at the bottom at the negative. Next, if you look on the back side of the meter, you have 2 ports here, a positive and a negative, and we'll be careful to take the hose with a white stripe, which we used as a positive, and connect it to the port here, and the negative on the other side. I'm going to plug in the power supply, and now we need to configure our meter to make sure that it's set to the correct probe. So we can turn it on. We have some bars going across. And then with the mode button, you can just push repeatedly until the display shows pitot tube. And then it shows FP, which is feet per minute. That's the measurement and the unit it will take the readings in. So let's go and take some readings. So here we are now in this reception area. I have my multimeter all set up and connected to the pitot tube. I also connected the straps, which are in the kit, in the suitcase, just so I don't drop it while I'm on the ladder. So we have the duct, and as I mentioned before, the multimeter will take the measurement and the reading in FPM, which is feet per minute. Our ASHRAE recommendation is in CFM, which is cubic feet per minute. So I will need to convert from FPM to CFM, and in order to do that, I will need the duct size. I prepared and I already took a measurement of the duct. It is 12 inches by 24. So let's go up on the ladder and take our reading. Our duct here comes with already some ports, so we can open that. And insert our pitot tube. With this duct, the airflow is coming from this direction. When we insert the pitot tube and take our reading, we want to make sure that the tip of the pitot tube is pointing towards the airflow. To actually take the reading, you push on the button Read and Select. And I will take 5 different readings. One thing to pay attention to as well is as you insert the pitot tube, that the tip is in the middle of the duct. I measured this duct, and this duct is 12 inches high, so I want to make sure, I had a little line here, that it's 6 inches into the duct. So now that we have our reading, let's go and download it to our PC. So now I'm here at my computer, and I would like to download the captured readings from the multimeter into my computer. And before I can do that, I need to install the software, which is on this little CD. I have already installed the software. And now I can connect the device, the multimeter, with the computer. We're using this little cable for that. It has a plug-in for the multimeter, and then a regular standard USB for the computer. There's a little red dot on this little plug. And there's also, on the multimeter, on the port, there's also a little red dot. And you would line those 2 up, and that prevents that the pins which are inside get bent or damaged. Once that's plugged in, all you have to do is connect it to your computer using the USB port. And make sure that the multimeter is turned on, and then you can connect it to the software. We can now download the data to the computer. We open up the software by clicking onto this red flow hood, click on Connect, Download. I'm going to save it on the desktop and call it Reception Area. Click on Save. And the data was downloaded successfully. We can now close all the windows and open up our Excel spreadsheet. And now we can see the data we've been collecting. We have 5 readings. And here in line 13, we see an average. The program calculated this automatically.
So the average FPM the system was supplying was 263. And now we need to convert that over to CFMs. In order to get CFMs, we need to multiply our FPMs with the duct cross-sectional area. We measured the duct earlier and it was 12 inches by 22 inches, which equals to be 1.83 square feet. When we multiply that with our 263 average FPMs, we get 481 CFMs as a result. And as I mentioned earlier, that is only one component we need to determine whether the ventilation in the space is adequate. Please be sure to check out ASHRAE Standard 62.1 2016 for additional guidance.
Now we know how many cubic feet per minute of air are entering our space. We can interpret this result, and if the airflow is not sufficient, we can make adjustments to our HVAC system. As mentioned before, airflow is one indicator of indoor air quality. There are many others. To measure other components, set up an account with our tool lending library at www.smartbuildingcenter.org.